Good morning, everyone. Hey, thanks for joining me in the API Management and Gateways track. I'm Brian Wilson, your host for the day in the track. We want to have time to enjoy the next topic, so just a reminder. Now, up front, ask questions. Chat's always open. Take the poll at the end of the session. If you're in the bottom left corner of your screen. We learn from you, so please put us to the test with those questions. That said, I'm going to hand it off to the team here, Ulas, Ivan, and Aiden, and we're going to cover GitOps principles and DataPower operations. So, Ulas, over to you.
Well, thank you, Brian. My name is Ulaş Çubuk. I'm the product manager for DataPower. Today we want to talk about one of our latest innovations, GitOps integration in DataPower. So, which actually we released this feature back in 10.5 CD release. But over the last year, so we added lots of improvements to our new GitOps feature. And today we want to also walk you through a demo. Basically, it's kind of a real life application. So we will show you how in our own lab environment we are making use of this GitOps feature. Very, very useful. But anyway, let's take a step back and talk you through why we come up with this feature. So because DataPower it is already supporting lots of mechanism for you to implement your CI/CD pipelines. I mean, even before this GitOps feature, you have your own. Many of our customers actually build lots of successful implementation to support their DevOps processes, and via DataPower's management mechanisms like CLIs, SOMA, or REST interface. So it was out there already. But when we're listening to our customers, we heard some challenges around that. So, and that's being said, the challenges was, usually the people who are responsible for maintaining the CI/CD pipelines, DevOps environments, were not necessarily expert in DataPower. So, and in order to maintain these scripts, it requires it requires some kind of basic DataPower knowledge, and it was taking quite a long time for some of our customers to build up those scripts. And another challenge was, of course, to maintain this ongoing basis. And the most important challenge was these custom scripts and procedures required for different DataPower form factors, which I will talk in a bit, can be different, because managing an appliance and managing the container world is as you can imagine, is quite different than anything else. So physical versus container. So this was one of the challenges, and of course, what we were talking through this together with our architects and some of our customers, and the industry is going for more a unified approach for both managing the actual application configuration plus the infrastructure configuration, and certainly the expansion of the Kubernetes-based or containerized application, adding now these kind of challenges. And in that respect, GitOps come to the picture, so which was coined by actually Kubernetes management platforms, right? So in order to manage the containerized applications, both in a development config and plus the infrastructure config, taking both into account. It's kind of not the same thing, but it's kind of GitOps is more like the evolution of the next step in the DevOps processes. But basically what it is, basically GitOps put the Git in the center of everything. So whether it's the application code, whether it's the infrastructure, config, so that all can be centered in the Gits, right? And which comes into play that so any a DevOps team in a company can use the same Git principles, can use the same perhaps Git commands for managing many different system and applications. So in terms of that, so we tried to align the DataPower operations, operations into that world, industry standard tooling and processes than ever more. So next slide, please. And if you think about it, and again, GitOps is an industry standard. So what I'm going to tell on the right-hand side of this slide is basically the principles that's been dictated by the GitOps standard. What are those? First of all, the most important thing, being declarative. So the system you are trying to manage, operate, it should provide a mechanism to be represented in a declarative fashion. What we did in that sense, the DataPower configuration is now expressed declaratively using JSON, and this was not perhaps the biggest challenge for us because, well, in my opinion, DataPower from day one was able to express the config in a declarative way, but using different formats. So perhaps, Aidan and Ivan can talk through that. And the second thing, so all this config should be versions and immutable. So basically the desired state of DataPower configuration are the usual understanding of that domain configuration. That state should be stored in a Git repository, GitHub, for instance, and that will enforce the immutability and versioning. And the third thing and the fourth thing, so very similar actually. So this configuration state should be pulled automatically. So or you should be able to pull this configuration and apply that configuration to your DataPower automatically. And for that sense, we have now basically a GitOps agent embedded in DataPower, which you can interact with your Git repository. And the last thing is, again, the state can be reconciled continuously. So basically that agent has the capability to observe the actual state in your Git repository and if you and apply the desired state. So those are the four principles that we cater when basically bringing you this GitOps integration. Next slide, please. And if we again to look into the DataPower gateway, that's typically the DataPower gateway architecture in the typical one in our customer environments. So the DataPower is everywhere, right? It's just in previous session I was also talking about. It's not just another runtime. It's a gateway, not just another gateway. Basically, as you can see here, it sits between different networks, different applications, and combines them together, links them together in a controlled, secure, and optimized way. So it helps you to enforce lots of security principles. So it acts like a security. It acts like a police, actually, security police, and this that relates to. In terms of the management of the DataPower, it's very important because you can basically use DataPower in a centralized and as well as decentralized fashion, right? So in your trusted zone, maybe you have multiple virtual DataPowers connecting to different backend applications. One group may be connecting to messaging and event-based systems. The other is connecting to the databases or mainframe systems. And you can also use DataPower as a kind of cloud gateway in your cloud provider using our virtual form factors. So in most of our customers, basically what we are seeing is they don't have just one installation somewhere, just one gateway. So they have multiple gateways in different scales, deployed to different networks, and sometimes you need to manage this different configuration, different data powers in a very efficient way. So that's why it's important to have this unified DevOps principles via our GitOps integration. Next slide, please. So just let me quickly mention the, again, a little bit complementary to what I said in the previous slide. So you have this different flexible deployment options in DataPower, right? So it comes in two flavors, physical appliance and the virtual DataPower, which has its own flavors, like you can deploy as an OVA, VMware, you can deploy it as an RPM on a Red Hat Linux host, or you can deploy it as a container and run it on Kubernetes and OpenShift, for instance. And yeah, if you think about it, as I said, most of our customers using multiple form factors like this. Yeah, it is extremely beneficial to have that unified DevOps experience. Next slide, please. So if you just to sum up the things, so why GitOps? As I said, there are many benefits. It's the evolution of the new DevOps kind of new subset of DevOps, which all the individual teams or the organizations can benefit from the GitOps to standardize their processes, increase the developer and operational productivity. So not only focusing on the developer experience, but also helps you to manage the infrastructure as well, and improve stability, reliability, and of course, GitOps also heavily, emphasize the security in managing your DevOps processes. So that being said, so let's dive into all these technical details that you were looking for and the demo. Handing over to Aidan. Please jump in.
Thank you, Ulas. All right. Yeah, so let's get into a bit of an overview of how you configure and work with GitOps in the DataPower. So as she mentioned, we introduced GitOps in 10.5.3, I believe, but it did merge its way into our LTS in 10.6.0, so it's available in LTS and can be used in any later streams as well. The GitOps configuration is managed at a domain level, so each application domain can configure a GitOps object, which would then define basically how the configuration in that domain is going to be managed. It is not supported in the default domain, although there are some GitOps related configurations in the default domain, specifically the addition of GitOps variables, which we'll talk about in a bit. The GitOps object in an application domain can reference a single remote Git repository. And within that repository, you can have multiple domains, but so you can reuse the same repository for multiple domains, reference that repository in each domain within the DataPower, and the GitOps agent will manage working out of that shared clone of that repository within the file system. So actually in the original version of GitOps in the CD branch before we merged it to LTS, we actually would clone each repository per domain. And so that was improved in the LTS release in 10.6. And so now you don't have to worry about having, big monolithic domains or GitOps repositories getting cloned more than once within the DataPower. So we've done some optimization there around file system usage. When connecting to the Git remote, you've got your standard SSH or HTTPS for authentication. And we'll talk a bit about the different modes of operation. But at a high level, we've got a read-only mode, which is going to be used for production, and then a read-write mode for your development. And then on the right side of the screen, and you'll see this again on the next slide, is just a high level of all of the various objects and actions that you can use and interact with related to GitOps. So next slide, please. So the GitOps is going to allow you to version control your domain configuration, and that also includes the local files. So any files that you have in your local directory, think about the style sheets or gateway script, things like that. All of those can also be version controlled, and it's automatically handled as part of your read and write operations. It is worth noting that crypto material is out of scope. This is a sort of best practice around Git, in that you should generally not be storing your credentials or secure, crypto material in your source code. So that should be managed outside of this process. Conflict resolution is also out of scope. So what this means is if you are, maybe peering with a coworker and you're working on a feature or some, developing new service, if you run into a conflict in merging your configurations, that merge and conflict resolution should be done on the remote. So think about opening a pull request on GitHub. You should do the conflict resolution on GitHub. There's no real approach for that within the DataPower itself. And we'll talk a little bit about how you can sort of feed into that process later. One of the big value propositions of GitOps is templating. So the idea being that you can have sort of a base configuration that gets deployed across multiple environments. Think about dev, non-prod, production, and you can have templates and variables allow you to mutate that configuration on a per environment basis. And let's go ahead to the next slide. All right, so here we're looking at basically the structure and the hierarchy of the DataPower GitOps directory tree that you would see on your Git repository. You'll see that everything is under a DataPower directory at the root. So DataPower GitOps does not care about what else is in that repository. So you can manage your scripts and automation infrastructure within that repository as well to be co-located with this, but we will put all of our configuration templates and things like that under this DataPower directory. This directory will get initialized on the first write if it doesn't already exist on the remote, and we'll also place down a README that has some intro information about what your various options are to use GitOps with. You'll see that each domain gets its own directory, and then within the directory for the domain, such as domain 1, you'll see a config and local. Those are essentially mirrors of what you would expect to see within your actual DataPower. The local file system here is an exact copy of what you would see in local on your DataPower. The config is, of course, a JSON version of the configuration. So that might be a little bit different from your typical DataPower configuration format, but that is the format there. And then you'll also see a templates directory. This is where all of the templates will get stored. And templates are shared across domains. They're not specific to a domain, at least in the Git repository itself. So you can use the same template across domains, and no concerns there. And then the templates can reference variables, which we'll talk about in a bit more detail as well. And I think that's everything for this slide. All right, so let's talk a little bit about the various modes of operation. So in read-only mode, this is really designed and expected to be used in production-like environments. This is where you want the GitOps agent to continuously reconcile your configuration and ensure that any drift is mitigated. For example, if someone goes into your production environment and changes a port or changes a path of some URI, GitOps would ensure that that configuration gets reverted to whatever the expected state is per the persisted configuration and version control. The commit identifier here can be either a tag, branch, or commit. So you can use really any sort of Git practice or convention you would like as far as how you want to track a remote reference within your Git repository. You could have a production branch that you merge to, and GitOps could be configured to just pull from the production branch, or you could pin directly against a tag or even a commit directly. So you really have a lot of flexibility on how exactly you want GitOps to reconcile the configuration from a version control perspective. Next slide. In read-write mode, this of course is not expected to be used in production. This is more for your development environment where maybe I've got a DataPower container spun up on my laptop and I can put it into read-write mode, develop some configuration, push that up to Git, and then use GitOps and CI/CD processes to actually deploy that into an environment. So in this mode, you have full access to all of the GitOps actions. You can do reads, writes manually, and it would be worth noting that you must specify a branch as your remote identifier, and this is basically just in line with the general Git practice. So in order to make commits and push those to a branch on your remote, you need to have a local branch checked out, and so here the commit identifier must be a branch because we'll be working off of that branch just as if you were developing in an IDE or a code editor on your laptop. And let's go to the next slide. All right, so if we look at the write process, so from the CLI, it would be the GitOps write action. This can also be done from the UI or even triggered by the RMI. The GitOps write is a holistic action which will persist all of the DataPower domain, application domain configuration and local files to the remote. So you can imagine that this is essentially doing an add for your config JSON and the entire local file system, doing a commit and then doing a push. This action does support configuring or setting the commit message. So you can, of course, put something meaningful there so that you can see that on the remote. And then there's a couple of additional options. Notably, the force flag is useful in the conflict resolution case where you might need to do a conflict resolution on the remote. What the force flag does is it will push to a unique branch on the remote instead of the branch that you're on. And that might be because there's already something else on that branch on the remote that conflicts with what you have locally. So by doing a force push, it will push to a new branch on the remote. You can do your conflict resolution on the remote and then pull those changes back down. Very similar to your general Git practice outside of DataPower. And let's go to the next slide. All right, GitOps read, basically the same thing and opposite. So we will pull all of the domain configuration from the remote, all of the local files from the remote, and apply that locally. Now this is a bit smarter than you would think. We do run all of the configuration through config sequence in DataPower, and there are some optimizations there to ensure that we're not recommitting objects that haven't changed. So you're not going to see your front-side handlers go down if you're not actually making changes there. So this is a intelligent read where we'll only apply the configuration that has changed on the remote. And of course, the local files will get overwritten if they're changed. And the force flag here will ensure that if there's anything locally that might conflict with the remote, the force flag on read will basically ensure that you do a force reset to whatever is on the remote. So it's a way to ensure that the data power is exactly matching what is declared on the remote. And this is actually the convention for, or how the read-only mode works, is it uses a force read to ensure that in read-only mode, your data power configuration exactly follows what is on the remote. And let's go on to the next slide. All right, so templates, this is a very deep topic. We're just gonna kind of skim the surface here. This is really powerful. There's a white paper, there's a bunch of documentation in the IBM Docs website. I would highly recommend digging in and looking at all of the value that you can use here. I think variables are a really big improvement. They allow, being able to reuse the same template across environments. And actually, let's go to the next slide to demonstrate that. All right, so there's a lot to look at here, but sort of on the top left, we can see a front-side handler, an HTTP front-side handler or a service. And we can see that the local port has been templatized. So, this configuration would have been pushed up to Git using a template so that that port could be configured per device. The next box down below that, where you see GitOps template HTTP serve, this is an example template that would have been used to produce that config. And you'll see that the value of the local port that's being changed is actually referencing a GitOps variable called HTTP port. So within the template and within the actual object on the remote, you don't see an actual port, right? It's just templated and then referencing a variable. And so that means that any device that wants to pull and deploy this configuration, that device must set that variable in order to deploy this config. So then on the right side, you can see two different environments. You've got a dev environment and a production environment. And each device or each environment there can set up their own value for the HTTP port variable. You can see in production, it's 80. In dev, it is 4000. And so dev could do reads and writes using port 4000. The template capability is going to ensure that that 4000 stays local to that box or that environment, and the remote config will stay exactly the same unless anything else is changed and not templated. And then on the production environment, of course, we can see the arrows are not bidirectional. Production's using read-only, and the variable is set to 80. So this flow just kind of demonstrates basically how you can use templates and variables to affect particular changes in different environments, and you can reuse the same objects, ensuring that environment-specific changes are managed appropriately. And let's go to the next slide. All right, so real quick, this is just kind of an example of how you might be able to use GitOps. So we could have 3 different environments at the top. These are branches as well as environments, production, non-production, and development. All of these could be, real deployed data powers in those environments, all configured in read-only mode. So they're continually following those branches. Anything that gets merged into those branches gets deployed, and then you could have, your test team going after and testing in those environments. And then when you're ready to move configuration through to the next environment, it's just a PR in GitHub or wherever you're managing your Git config. So this just sort of demonstrates how you can apply GitOps principles and practices to managing DataPower config. And let's go to the next slide. All right, so just wrapping up, some best practices and troubleshooting tips. One thing that we did add in the 10.6 release is a template builder. So when you are editing or building your templates in the DataPower UI, there's an option to basically test the template, and it can show you before and afters and show you the exact JSON that's being generated and used to execute those templates. It's a really powerful tool to build more complex templates and make sure that they're working appropriately in your environment. So highly recommend using those. For production environments, you should be using read-only mode, of course, and setting your read intervals to whatever makes sense for that environment. The read interval will be how often GitOps is going to pull and reconcile the configuration from the remote. So you should, take into account how long it takes to execute the domain config. If you're deploying a bunch of services, how long does it take for those services to be deployed? Let's see, we've also got a number of status providers and logging facilities within GitOps. So using those to your benefit when troubleshooting. There are status providers for each GitOps operation you do. So a read or a write will have an operation status that you can follow up with, as well as the template execution. There's a way to follow those in the status providers and logs. So very helpful for troubleshooting template executions. And of course, GitOps variables are a really big thing to use for templates and ensuring you've got an easy way to manage the same configuration across different environments. Also, it's worth mentioning that we should not be using GitOps in an API Connect domain, as the API Connect domain configuration is, of course, managed by API Connect. All right, and let's go to the next slide. All right, so just a few more takeaways before I hand over to Ivan. GitOps is only supported in application domains, so you cannot use it in the default domain outside of setting up your variables. The object is singleton, so there's only one GitOps object in that application domain, and it's defining how that entire domain is going to be configured. You need to manage crypto material outside of GitOps, as it's an anti-pattern to put credentials and secrets into Git. And templates should be used for managing objects across different environments, and you can use variables to make environment or per device changes. And we didn't go into detail on this, but one of the nice things about GitOps in the context of Kubernetes is that because the agent within the DataPower is pulling the configuration and reconciling it, you don't have to change the lifecycle of the pods or the stateful set to roll out those changes. So if you were managing your DataPower with config maps and the operator, making a change does a rolling update to that stateful set, which is a standard for Kubernetes. But of course, with GitOps, you can avoid that and have the DataPower pull the configuration directly. So that's something to be aware of, and I think a nice value add for this feature. And I think that's it, and I'll hand it over to Ivan.
Okay, excuse me, thank you, Aiden. Let's see, next slide. By way of introduction, what we're about to give is a demo of the GitOps integration as used by the DataPower engineering performance team. As you can imagine, doing performance work, we have a lot of appliances in various form factors, etc. And in one of those use cases, we use DataPower appliances as a backend service simulator. I call it the idealized backend API endpoints. So we'll present a little demonstration of how we're using the GitOps to manage that application that implements our idealized backend. So why is our experience interesting? And the second bullet here is really my favorite. I happen to sit next to Aiden, and when I'm using his GitOps implementation, he hears me cuss. And he also sees me smile, so that's good. We work together quite closely, and so this is a valuable opportunity for my use and experiences to feedback directly into Aiden and his squad at doing the implementation of the GitOps agent itself. So this is basically going to be some pro tips, this demonstration, some pro tips around our journey into using the GitOps features to manage a fleet of DataPower appliances that's, I think, maybe 9 or 10 appliances strong. What does the DataPower performance team do? We're responsible for optimizing the DataPower hardware and firmware. This is just just by way of introduction of what are we using these appliances for, and what are we using the GitOps on those appliances to do. We're going to focus primarily on the back-end implementation that I mentioned a minute ago. That's what I call the idealized responder, and we manage that domain and its applications through the Git integration. This is just a quick topology of one of our test environments where we do performance work. And this idea of the idealized backend cluster, that's where the focus of this demonstration and presentation is. We use GitOps on all those data powers you see listed there, DP1 through DP9. We use GitOps to manage the application domain on those appliances. And the demonstration I'll take you through uses several of those specific machines. What does idealized mean? What we're trying to do in this application domain, again, it does run on DataPower appliances. We're trying to be able to offer very specific latency boundaries, and in combination with very low resource utilization. So we started using DataPowers as backends when we realized that using real applications, maybe a Java or a WebSphere implementation, are some of the things that we used previously, and they require a lot of resources to run those backends at very high throughputs, right? Because we're testing these DataPowers up into the thousands of TPS, tens of thousands of TPS on the latest, the X3 appliance is a big machine. And so we have to have backends and load drivers that are not going to inhibit the test of the DataPower itself. And so I use this fleet of backends to deliver API endpoint services that are idealized in the context of using as little resource as possible. Okay, let me switch, share, and go over to the video, and I will take you through the GitOps use case in my environment. Here is that video, and let me start it playing.
SSH CLI access to 2 of the DataPowers in the back end cluster. One is push enabled. That is the DataPower configuration that's used to populate the Git repository. And then I'll also be showing one of the read-only members that receives its configuration from the Git repository. So we'll go ahead and get started. First logging on, this machine is our read-write enabled DataPower. We'll switch into the proper domain, the idealized backend domain. And we'll do a show of the GitOps configuration object. We see that it is enabled for read-write mode. We see that it's using the repository that is designated for this purpose. The commit ID is to the dev1 branch within that repository. And I'll give a tour of that repository as well as we move through the demo. Okay, so that's our read-write machine. Let me log on to our read-only machine. So switch into the idealized backend domain. And then I'll show the GitOps configuration object. Here we see this one is read-only. It's polling on an interval of 1 minute. So that means it goes to the repo to check for updates once per minute. It's referencing main branch. The commit ID that's being used is for main. That means that it's using main branch in this repo. You'll notice that that's different than the push enabled machine. That's writing to the dev1 branch. And then we use conventional pull requests to merge the dev1 to main after we're comfortable with any changes that are being made to the configuration. And then once that pull request is completed, all of the read-only members of the cluster will inherit that configuration. Okay, let's see. Next, I think what I want to demonstrate is adding a new cluster member to the backend, idealized backend cluster. So first, what I'll need to do is SSH over to the DataPower and log in as admin. First thing I will do is create a domain. So I go into configuration mode, and the command to build a domain is just domain, and I'm going to call it ideal backend. Okay, excellent. Now I will exit that object in order that it gets created. And I'm in the default domain now. I'll do a write mem to capture the existence of that domain in the base configuration. Our idealized backend domain on our new machine that we're adding to our existing cluster. I'll go ahead now and create the GitOps object using the CLI to do that. I've created the CLI command separately, have it saved in a text file, which I'll just bring over and paste in. Here you can see those GitOps property options that I've selected. This is the read-only type config. Oops, let's change that interval to a 1 so that it aligns better with the other read-only members of this cluster. And we'll go ahead then and exit, and that object will get created. You'll notice I created it in the disabled state. I'll do a show GitOps, and it is currently disabled. Just as by way of observing what's going to happen when I enable that object, it's going to pull the repository at main and pull down the domain config that includes all the gateway scripts and multi-protocol gateways and front-side handlers, etc., that are part of that domain. So by way of example, I'll just show that there are no source HTTP. That's the front-side handler that is used in that domain. There are none defined in this domain yet. And then once I enable that GitOps object, we will see those appear. GitOps, let's see, I want a semicolon default, max. Okay, so that GitOps object is now coming up. We'll do a show on the object. We'll see that it is now in operational state of up. And so given time, we should start to see, oh, it's already done. The domain contents for this idealized backend domain have all been downloaded from Git and should be operational within this DataPower. So that's an example of adding a new member in read-only mode to pick up this domain configuration. Now that we have seen the DataPower side of the configurations, let's take a look at the repository itself. I've logged in using the browser, and you can first first note the two branches, main and dev1. Remember, main is the branch from which all of the read-only members are pulling, and dev is the branch to which the write-enabled member is pushing. We'll stay in main for now and just have a look at what files are included in the repo. The first is the domain's configuration. All the DataPower objects that are required to run the API Service Simulator application, including, you'll recall the front-side handlers that I showed using the DataPower CLI after adding a new member to that repository. And we'll just locate those source protocol handlers here in this JSON file. You can see it's reasonably large file. We'll go to the bottom line here in just a minute. But by way of demonstration, I wanted to show you those objects that I had referenced using the DataPower CLI after we completed the addition of the new machine to this repository. So these are those front-side handlers. Now we'll also just to give an idea of the scale of how of this JSON file. We go down to the bottom, we note that it's about 1,889 lines. This is a small domain, actually. Doesn't have a whole lot of stuff in it. As I mentioned earlier, it's idealized, and that means that it's doing as little work as possible because I want it to be as little resource requirements as possible. So this is the domain config file. Then we also have the local file system, the local directory of the file system in that domain. As I mentioned earlier, also, most of the work that I do is benchmarking, and so I tend to be fixated on different payload sizes. You can get an idea, as we iterate over payload sizes, you can see the various sizes of payload we might require. And then we also have some very specific response content, modeling very specific back-end endpoints. We'll demonstrate adding a file to the local directory of our idealized back-end domain. And I'm going to do this using a generic Git client. I'm not going to use the DataPower push-enabled machine. I'm just going to go ahead and add a file to the local directory using my desktop tools. So I have a file explorer in the local repository, and it's currently connected up with the dev1 branch. And so I'll paste in a new file. This is a PNG file that we're using to advertise the TechCon 2025 event. VS Code recognizes the update to the file system. We'll add a commit message. We're adding PNG file. I might want to say PNG. Okay. Commit that. And then we'll sync it. And then we'll go back over to the Git repository, just using the browser to show that file has arrived. And then we'll create the pull request to merge it over to main. And then we'll go to our read-only machines and look for that file to arrive on the file system of those machines. So now we'll take a look back over here at our Git repo. We're in the dev1 branch. And we're looking for the existence of our PNG file. Refresh the view here, and there is our PNG file. Okay, so right now it's in the dev1 branch, and so I'll go ahead and create a pull request to move that over and merge it to main. So I'm going to do a new pull request, and I'm using dev1 branch, and I want to create a pull request. This is adding PNG file to the local of idealized backend domain. Okay, and I'll go ahead and create that. And that work gets done. Okay, it looks like that was reasonably quick. Now I'm going to go ahead and merge that over to main. And next we will look on our read-only DataPower machines for the addition of our new file. I had done a directory listing prior to the merge on this machine, and here we see that the file is not present. And then I've done another directory listing after the merge had completed and the read-only members had pulled the content, and here, of course, is our file. And so that demonstrates how we can add files or change files directly in the repo with our desktop tools. Next, I will demonstrate editing a file, responder.js, which is a gateway script file. It's part of the implementation of the idealized backend service. And what I'm going to do on the DataPower side first is show the file so that you can see a particular line in the file as it sits on the DataPowers before we make this change. The particular item that I'm going to change is this commented line that you see here, the request file 1 KB JSON or default.json. This is just part of the logic of this gateway script. And I'm going to go ahead and edit that using VS Code and then propagate those changes through to the read-only DataPower members. So let's see, where is that? Here is that line in my dev1 branch of the repo. And so I'm just going to flip the comments and make the request file name in this particular if clause equal to default.json. I'll go ahead and save that, and we'll go ahead and edit .js. We'll commit this. Okay, now we're back, and the pull request and merge have completed for the edits to the responder.js. I will now show that file again on our read-only, one of our read-only members, and then I will search for the edited line where we flipped those comments, and sure enough, here we see where that change has propagated to the read-only cluster members.
Okay, so that ends our demonstration portion of the presentation. I hope that was informative and helpful. You're certainly welcome to download it from the TechCon site. Feel free, if you have questions, you can probably figure out what my email is. I'm glad to help anybody that wants to give it a try. Should we go back now and open up the Q&A, I think? Are there chat questions, Brian?
There have been quite a few, and Aiden's been doing a masterful job of getting them answered, and a little help from Ulas. And so right now, there are no questions, but let's put out the question to our attendees. Anyone have a question they want to try and get answered right now? And of course, as Aiden put in the chat also, office hours will be available. So, if you want to get into a longer conversation or topic, that'd be this place to do it. Speakers will be there, and that's what our office hours are for.
Yep, I'll definitely be there this afternoon. Looking forward to that.
I will be as
Fabulous.
well. And I'd also, this is, a relatively new feature for us, and, we've improved it over a number of releases, but, certainly welcome additional feedback, or if there's any other enhancements you'd like to see around GitOps, we're definitely interested in that feedback. So if you have a use case that you don't see quite covered here, reach out and we'll try and figure something out.
Yeah,
And
please reach
again,
out to any of us. Yeah, so you can open an idea RFP from the idea portal or directly reach out to us. So yeah, we really want to hear about your feedback and how you can getting along with this new feature. Yeah.
Yeah, and Jay did make the comment. This is a cool feature, long awaited.
See, now I'm smiling broadly. Aiden.
Yeah. Our customer,
I can see it from here.
customer is Ivan. Ivan is happy with this feature. So yeah, if he's happy, anybody can be happy. So
That's right.
That's
I'm notoriously grumpy.
Yeah.
It's
I
hard
didn't want
it's hard to
say
keep
that.
Ivan happy.
Yeah.
All right, everyone. So then, the smile. All right. So thank you, everyone, for attending. Again, please take a minute, put out the poll there, the survey questions, so we can get your feedback, keep improving. And again, coming up next is Adam Chire, again, co-founder of Siri. Today, he's going to talk about how AI is driving innovation. So again, remember office hours. Enjoy Adam. 15-minute break here with optionally listening to Adam while you grab lunch, water, check your email, whatever you need to do. But again, come back. Let's keep the conversation going. Thanks for attending, everyone.